we're looking at a way to measure force. So first with the help of mass, and this is also indirectly with the help of mass, but we are making use of spring as well. Okay, see, for all of this, the pre-requirement is bunch of masses, bunch of substance whose mass is known. Okay. With known mass, with known mass. I have an object and the mass of this is known. That's your pre-requirement. Okay. So now, what can we do with this? Well, case known. I need to standardize. So what I do is I'll take a mass which I know of and I'll apply a force which I have a feel of and get to see the acceleration. Okay. So here, what we are at is we have F1 and M1 that is known. Then we'll go to this case, unknown. Unknown what? Unknown force. Here we knew of everything, So here we have, say, M2, or we don't choose the object directly. We are applying a force. We have a feel of it. We are applying a force, but we don't know the value. This is unknown. But the acceleration we will take, we know the mass. We are applying the same force on different object. Then we get some object whose mass is m known. Okay. So we know about this mass of this object. We get to see it accelerate such that its acceleration is same as that of the first one. So the rate at which it changed its velocity, say it was at rest, the rate at which it moved, right? That we saw to that it is same as that of A1. Okay. So here, what is known here clearly, we know of mk is known. So how I can do this is I can keep changing. I can do trial and error basically. So using trial and error, I keep changing the mass so that we end up with this acceleration, right? With this entire thing in mind, okay, what I can do is I can do some math as A1, or I'll do it here, fresh, as that's not needed, as A1 is equal to A2 from force is equal to mass into acceleration. We can write F1 by M1 should be equal to F2 by M2. So here, this is known, this is known, this is known, this is the unknown. So all I have to do is F2 will be equal to F1 by M1 into M2. So as simple as that. Okay, so you can keep doing this. So whenever we get any force that is unknown, I can keep switching. This is K, by the way. So we will not exactly know which force we'll end up with. Sorry, which mass we'll end up with. That's why I written K. So we keep changing so that this force will create the same experience as that of the known force, right? We can define it and so on and so forth. So this will be clear with this example. Okay. So with a similar idea, we can calibrate a spring. What does that mean? So let me show a video. Say I have a actually particular device actually. Just a second, guys. What we have here is a calibrated spring. So we are looking at a spring over here. Okay, let me show the device. See, can you see that? So actually, sorry, I misspoke. The spring is over here. This is a spring and this is the calibrated device per se. So the marking is known as calibration, right? So you are kind of measuring, we are measuring over here. Okay, so this particular setup measures this particular, here it's written as Newton. I'm able to see Newton. Of course, you guys, it's too small for you guys. So this is 0 and I'm not able to read much more than that. So how do we do this? This is a calibrated spring, example of a calibrated spring. How do we get to this? So now to calibrate a spring, to measure force, follow the following steps. First is 0 is out. So 0 it out. That is, hang the spring and mark the resting position as the 0 point. So basically this, okay. So here in this case, the spring is not at, the system is not at lifting this mass. Okay, the system is not at lifting the mass. Right? So this is 0 of the system. So this is where the system rests when there is no force applying on it. Right? Next, add a known weight, known mass basically. Hang a standard weight, say 1 kg on the spring and mark the new position. This represents a specific force, example 9.8 Newton. So what they're telling is, you hang the object like this, see where the system will come to rest in. This is not meant for this particular discussion, but this is meant for something else. But anyways, I'm making use of it. So after you lift it, maybe it will take a second or two. It'll come to a particular point. That point will be your 9.8 Newton. Or if you take approximately 10 Newton. Now, let me put it as a diagram. See, it's quite simple actually. We have a spring. Okay, if you want to do it at home, and if you have a spring, a decent spring, so we can do this, right? And say you have a pointer like this and say the hook like this. Even this is good enough. So what you can do is, you can start off this way. Okay, I have this setup. I know that when I put my spring in rest, I have the marking over here. So what we can do is, we can say, since we are trying to do it at home, we can put a paper in the background, something like this. And it's not practical per se, but just hear me out. And you mark the 0 and you write, okay, this is my 0 Newton. That's it. Then what you do is, you take up, right? You take up a mass, the same system. Actually, all of this has to be on the same screen. That's better. And we have this. Right, now what happens is, we know 0, right? That is there in our hand. We know 0. Next, I'm putting a known mass. So what will happen? Obviously, the spring will extend actually. Not like that. Maybe like this. And this will continue to be the same hook. But in this case, I have a mass that I have hung. and this is say 1 kg, right? And we know from force is equal to mass into acceleration, and we know that acceleration is 10 meter per second square, right? So this point, okay, let me change the color. This point, where is it? This point will be approximately 10 Newton. That's it, as simple as that. Okay, because I'm taking this as 10 meter per second square, and I know this is known, and using F is equal to m into A. So then I'll end up with 10 Newton, right? All I have to do is substitute and we are done. So I can keep doing this for different masses. Say I know half a kg, then what will I do? What will I get? I'll get something like this at this point. When I use half a kg, I'll get I'll end up with this particular point being over here at this height. And this will be 5 Newton. And you keep doing this with known mass, and you will end up with a scale. And that is nothing but your process of calibration. So where is it? Here. So this is how you create the scale. Repeat this with other known weights. Since force is proportional to stretch, the mark on the scale will be evenly spaced. This creates your calibrated scale. Okay, so that is your funda of how you can make your own measuring device. Right? So this is how you can measure the force. So what we can do is now you guys can write this heading and write this idea. And next the calibrated spring heading. And this diagram helps. So paper, say this is a clip and spring.